Let's talk about the logistics of the exam a little bit. Cannot minimize that. All right. Are we all clear about the content, what the exam will cover? It's okay. So there won't be any question like per se from exam one part, but you need to have the knowledge to carry, right? For example, you need to define reference frame, you need to know what they are, right? But there won't be any specific problem from exam one part, but I'll call this like comprehensive because you're carrying the knowledge. But specifically, it's anything after exam one material up to the numerical method of inverse kinematic, because we then go through that. What's that? Up to, it does not include, excluding the numerical method. It wouldn't be part of the exam anyway, because like you don't have your computers to code, right? But just wanted to be clear. Your homework counts, your CPs count, things we talked, lecture, any of those. All right. I do have, I think I posted, yes. Okay, so I want everybody to open this. Exam will be in class. You can bring one cheat sheet, one page, specifically prepared for your exam 2 material. Same rules, no solved problem. You can't have your DH table for a specific robot and then fill it out. You could bring those 4 sentences, how to find alpha and A and all of those. Anything that is a formula, you can write in English, not in your, just in English, so I understand. Of the process of things, that's okay as well. All right. You can also bring cheat sheet from exam 1 if it makes you more comfortable. All right. I'll go over the exam sheet, the same before exam, I'll check your cheat sheet. All right. But I'm hoping everyone knows how to prepare those now. Now, the plan for today will be, I'll show each questions and you will spend time, try to solve it. Then I will solve it. Sounds good? So the idea is that I want you to go through your lectures to mark which information you needed to solve these problems. Again, the questions are not going to be difficult even in your exam. The idea is if you know which information you need to use to solve this. So connecting the dots, all right? Same rules as the previous exam. This one is out of 60. There will be 3 short answer questions, which is accumulates to 10 points, something about velocity kinematics definition, something about Jacobian, and there will be a short problem about Jacobian. So this top part should take you about 8 to 10 minutes. So it's more fundamental things that you would need to know or something very quick to solve. All right. On the problem section, you will have some sort of frame assignment doing finding DH parameter. So again, please read the question very well and answer what I ask you. So here I'm asking assigning the reference frames, frame 0, 1, 2, 3. And so why I'm asking 3 frames only? Well, I'm asking 4 frames, but frame 0 is your base frame, right? You have, I'm asking 3 frames because you have 3 joints, right? In the exam, I might not tell you how many frames, but you always show base frame plus all the joints frame. If you identify the end effector frame separate from your last joint, it's your choice, but then it has to show up in the DH table and it has to be correct. Meaning that if it's not a joint, then what does it mean in DH table? How would it look like? All right. That would be your responsibility, but it's easier if you didn't do it. If you just get your last frame on your last, and your end effector frame on your last joint. Yes.
Right. So as long as the end effector is like the correct like extension, it's not like labeled distance. It's just equivalent to the last one.
Yes. Okay. Yeah. All right. So start this. I'll give you about 10 minutes. All right. Assign all the frames and start your DH table. So if you see something like this, I'll let you complete, but so if you need to know what this distance is, you can give them distance, right? Like a link value. Result of frame assignment. Any question about frame assignment? Check the data tab. So there is a case of you could choose any direction type of thing here. So you see that in this example, I didn't give you the direction of the rotation, right? But we know that you're following right hand rule. So define a direction for rotation, and then I can define the z-axis. So the first one, rotating the z-axis is upward, hence rotating counterclockwise. If you want to rotate the other way, your axis will go down, but I suggest not to do that. Something up. For the other one, you could go either way, right? Counterclockwise or clockwise. Again, either way, you have to have this in the right direction. So I took my in that direction, so it has to go counterclockwise. The third one is a box, shows the prismatic joint. You see that none of those joint variables were on the robot. So if you see in the exam, you have the link length given to you is different from the joint variable. You always have to define your joint variable. Unless it explicitly is defined, that is theta 1, theta 2, or theta 3, right? Otherwise, you'll have to. So I kind of also marked it today tail. So that's my D3. I mark A, B, C as the link length. If I need them and if they need to show up in the table, they will show up. If not, I'm fine. After the formula will tell me. Now, between C1 and so for X1, the X axis has to be common perpendicular on the 2Z axis, right? And you can see that you could take either direction. Now, if you go with the second one, it's also correct, but your DHA will be different from what I was told here, right? So I'm taking the first example for X1. Now for X2 direction, again, your X2 has to be common, has to be perpendicular with the Z1 and Z3. They're in the same page. So anything, any direction that's perpendicular to that is acceptable. So you think about the circle, right? Anywhere on that circle could be. I just make my life easier since I know later on I need to define alpha and A and all of those. I just keep them in the same direction if possible with my X1 parallel, right? So I know there's a lot of zeros in my table because of that. For the third one, I'm matching it with my X2 direction. It's easier again, all right? So if you could make your life easy, do so, but it should be correct. Should be able to follow the rules to that. Now that I have all the direction, finding my DH table should be fairly simple, just following those 4 sentences, right? So what I'm going to do is I'm going to draw all the axes here and fill out the table. So I want you to follow and see if what you saw in the axis was the same thing. If you want to continue working on what you are doing, you can also do that. So I know that I'm going to have this table. This is the link I, 1, 2, 3, alpha I minus 1, A I minus 1, theta I, B I. So I know that because I put my first frame, my 0 frame, the same direction at the same location on my frame 1. Row 1 should be very easy, right? What do you have? 0, 0, theta 1. I'm going to put a star to show this the variable and 0. Now, 2 and 3, I'm going to draw them. For I equal to 2, I need to find alpha 1, A1, theta 2, D2. So have Z1, Z2, now X1, right? I need to find the angle that Z1 currently is making the building between Z2 along that axis and the fired. Then here, Z1, Z2, A is the, bless you, is the distance. You see that they are intersecting, so that's 0. Then theta 2 is x1, x2. The angle they build with each other about Z2, they are parallel, so it's 0. And then D2 still have x1, x2, we need their distances along Z2. We actually need to check what this distance is. So x1, x2, I defined it as B, so I'm gonna write B here. Now I'm gonna fill out my table, so hold on. Take a look at what I'm doing. So A1 was 0. Theta I have a fixed, I could have a fixed value for theta plus the variable, right? Why? Because this is the removed join. So it is good to identify what is the variable. So this one is theta star 2, right? Plus 0, which is a star 2, and your DI is B. Now ask your question. Who was asking? That was it, right? So either there are two ways. Either identify what each of these links are connected to what join, put that in there, and then have a like a box that some number, fixed number could go in there, could be a 0, right? So you won't mix them up. So any row should have one join variable, either here or here. Now the first two are your really join, so I knew that this is going to be removed. The third one, what do I expect? Which line I expect the star? It's a prismatic, right? So I know I'm going to have a D3 star plus it could be a variable or not. I don't know yet. Here?
Yeah.
So A1 would be the distance between Z1 and Z2 along X1. They are coinciding. There's no distance in that direction, just 0. Yeah, one.
How do we talk to like
So sometimes it might not show up. It means that it does not impact. Because so it will impact the position, but it will not impact the orientation of the robot because you can scale it all the way up, all the way down. All right. Yeah.
So if you just for your axis, you want it to always be like very simple things like one off one the page, make it here or we get it like one.
Doesn't necessarily
Pretty arbitrary.
Well, it's not arbitrary, but I don't.
Okay, so what he's talking about is, so in terms of how you reference your axis, because obviously Z is in the direction where you know that, but where you put X, like, is it actually going to?
So as long as you follow the, for example, for the first, so X1 could be in two directions, right? Both of them are correct. So it's not arbitrary. They're both perpendicular, right? So now let's say instead of going into the page, I got it out of the page, right? And then for the next one, I got it into the page. What's the angle between them? 180. So 180 will show up later, and that sine cosine of 180 will fix the problem, right?
But you don't want to do weapon, right?
It's
You're going
based on
in
the
and out.
Z's.
So that's why we first define our z's. We fix the z's, and the x's are perpendicular to the page, the plane that the z's build with each other. All right. So then it doesn't matter which way you go because the angle between them, the twist angle, will fix the problem. Now, back to your question. So when we follow the DH parameter, because so you remember we had a big matrix, right? So we said so everything in this method is built upon from one frame to another. We can show the motion from one frame to another transformation based on 4 different transformations. A translation, a rotation, translation, a rotation, right? So sometimes some of the links might not show up because you might, like, based on this method, you might not need to do the translation along that, right? and some of your link will show up. So if in your DH table, you didn't get all A, B, and C, don't worry about it. Now, if you get the axis in a different direction, they might show up.
So how is that going to account for the end effector being by factor A? Because if it doesn't include the how is that compensated by?
So you will have P01, P02, P03, so 4, because here, if you take your frame 1 at the corner of A and B, then A1 will show up.
Okay.
So here we are defining the location of the frame, not the location of the links.
Okay.
That makes sense. So that link does not impact the orientation of the end.
So in a sense, are we just saying A is equal to zero?
You could assume there is no.
Yeah, sorry.
Yes, there is no offset. Now, if the offset was important, then we need to make sure that we get our axis in such a way that the offset shows. Okay. All right, so for the third row, let's hear what you have, then I will draw. What do you have for alpha 2? So this is I equal to 3, so you have to have alpha 2, A2, theta 3, D3. First of all, what kind of a joint we have here? Prismatic. So I'm expecting to have D3 star here, right? So the joint variable shows up under D. Now, alpha 2. The angle they built is 0. Now we need the distance. So along X2, what's the distance? 0. Now X2 and X3, what's their angle along Z3? 0, because they're parallel, right? So this is also 0. So there is no angle related to configuration between them, so we can move on. Now let's take a look at D3. For D3, we have our X2, right? Then we have our X3, and we want to know what's their distance along Z3. So they're obviously shifted. There's a distance between them. So we need to go and take a look there. This is that distance. So we are looking at the frames, right? So this is, I called it C plus C. So meaning that in your big matrix, there will be a fixed distance because of the configuration of the robot plus however much your prismatic joint is. So Adam, if you wanted to show that, if you put your the origin of your frame there, like for Z1, like Z1 and X1, then this will show up. And you see that in literature, some of the traditional method, that's what they do. Yeah. All right. Why you don't care about that? Because that's a fixed value, right? It's in the Z direction, you can just add it to what you pass. You don't have to bring it. It matters. It's a fixed value that you can add to. So let's say, so I understand your question. It's a good question to think about.
Yeah.
So let's see the distance here. So this thing can rotate, right? In this direction, but this is kind of fixed.
It's no matter what.
So why would we make our matrix too complicated? Right? You can just add it at the end with the offset. So, that's why you have to look at your table and your robot, make sure what's happening. In the other method, they will do this, so they will consider that distance when they're assigning their frame, making sure that distance shows up in their table, and they carry in all of their calculation, which is a little bit more complicated, or maybe more numbers. They're the same, there's no difference.
So this method of doing, yeah. You always do.
Can you repeat that last sentence?
We always get zero for that,
For the first row?
like in your 10%.
No, this would depend on, like, you have 4 sentences that you follow on findings, right? And draw that in. So if there was so here for 801, if this one was a slightly shifted,
Oh, okay.
then you had a distance, right? Depending on how your robot looks like, you draw them there. But again, so Adam's question was why A1 doesn't appear in our table? Because the fixed number based on this method, it doesn't matter that fixed number, all right? But to find any of these, you have to follow that 4 sentences. If you do that, you'll be successful. This will be a correct table, all right? You'll see that any one of your CPs, if you remember, frame 1, I think, or frame 2 was not on top of the frame, it was a bit higher. They wanted this to show up that number in the view. That's why they did it. You don't have to, there's 2 ways of doing it. So this is a slightly easier because there's more zeros in your matrix, basically. Now, we found these tables, right? That's done. Now, if I ask you to find the transformation, then you have to go to your big matrix, plug everything in. Right? So, don't do the extra work, because then again, you show me you didn't understand what I asked and you lose points. Some of you did in exam 1, took point off. If you wrote more. All right. Question 2. So this question will be about Jacobian. All right. There are 3 different methods of solving Jacobians, right? You need to choose which one. So spend 5 minutes on this. Before solving it, look at it and find what is the best. This is one of those evil questions. We need to spend some time to think about kind of best way to do it and you take this on 5 minutes. Okay, if you do this, I'll give you 0. And you tell me why is that. Yes, that is correct, but I will give you 0 for that. You need to tell me how to get it. But you need to tell me how to get it.
Wow.
Let's go back. Yes, it is as easy as you think. It's, yes, a lot of writing, but you need to make sure you write enough. All right, so let's read the question very well. For the Jacobian, find the Jacobian matrix that relates the joint velocity to the linear velocity of the end effector. First of all, which part of the Jacobian I'm asking? JV. So identify that. Now, if you give me all of them, you get a 0 because you don't know what I'm asking. So it is really important if you know which part is the JV, right? Now, if you go back to your Jacobian definition, your JV is right? The rate of change of the velocities, well, the partial derivative of the velocity with respect to the joint variables. How many joint variables do you have here? 3, right? So, times 3 columns. This is always 3 by something. So, we know it is 3 by 3. Now, what are your joint variables? D1, D2, D3, right? So, I know that it will be D1, 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 D2, D2. So all I'm doing right now, just understanding what is the problem. What am I being asked to solve? Why does it matter that someone tells me? So you're trying to find that. The velocity, finding velocity in X direction, and then getting to the partial differentiation with respect to one, the rest. Now, if you find this, that is your problem. Let's get specific and especially about your problem. What? Because it's a velocity. The velocity kinematics, right? Well, you're trying to find the Jacobian matrix that relates the joint velocities to the linear velocity. So we need a matching between velocities. All right. So let's find the velocities. What method should we use? We have explicit, implicit, and any of them work. Which one is better? Oh, you're saying why these are the velocities? Is that was your question? Okay. All right. Nice. So, what's your X position of your end effector? If you look at the robot. What's the Y direction of your end effector? What's the Z? Right? Now getting the partial differential of that. Sorry, yes, you were right. I didn't know what I didn't understand first what you asked. All right. So now we need to get partial derivative of x with respect to d1. What is it? 0. All right. So if you do all of that, 1, 0, 0, 0, negative 1, 0. Now that's our JV. So our x dot now this is 0, 1, 0, 0, 0, negative 1, 1, 0, 0. D1, D2, D3, which these are D dot 2, D dot 3, D dot 1, if I'm not wrong. So we needed to find the Jacobian matrix that relates. So that would be the Jacobian matrix. If I ask the kinematic forward velocity kinematic expression, you would have to show this one. Now, I brought this for your exam practice exam to show you that depending on what the problem is, you would need to choose which method. Now, you could have gone any of those other methods, right? And you will get this correct solution, but it will take a lot longer. Really? Let's say DH table, had to write a DH table. Or if you want to do implicit, you have to do every one of them separate. But there was a easier to do them from the If I didn't ask what method to use, you can choose any method that is more comfortable and you think is fast. If I ask you use this specific method, then you have to. So in your cheat sheet, write what things are. Right? So when you have the end effector position, like the one from your homework, right, that's explicit. Explicitly from the position, you find that. If you're going kind of like one frame by one frame finding the velocities, then that's your implicit method. If you're doing this, that's your direct method. Because of having P, you can easily find the position, click on the variable, and then just get the difference. Make sense? So exam question could be like as simple as this, or it could be like your homework with more writing involved in it. Yes? So this is with respect to, so this is your base Jacobian, right? In frame 0.
Oh.
So we are talking about basic Jacobian, which is always in our frame 0. If you needed to find it somewhere else, you just multiply by the rotation matrix thing. The third question would be, we solved this already, I think, in one of your in our class. So I'm not going to solve it here. I'm just going to give you the solution. And it would be inverse kinematic. If I didn't tell you, you could use anyway, but if you could solve it with geometric, go for it. If you could use analytic, you could do that as well. Right? It would be simple enough that you could also solve it analytic. One. But geometric is also. I already solved this. So, okay, that's yes. Let's just talk about that so we get that out of our system. Now, here, this is your z-axis, right? I'm assuming these. As soon as I put it there, that's my assumption that those who are prismatic are going to move that way. You could say, no, it could go the other way. Sure, it can go the other way, right? It could be moving things this way. But the thing is, when I say C2 that way, the negative, whatever number will go. So I'm showing the positive direction of the z-axis. Now, you have A and B, but what I want to show here is this is my D1, this is my D2. These are my joint variable, and this is my theta 1. Let's do that, 2, 3, so it follows kind of. So I didn't show the joint variable, you were showing it. So you need to do those basic things, and then you can test on your friend and go on. So first, find your joint, put the variable, find your z direction, assign it, and then find x1. But find x's, and then solve for the rest if you need it. So What information I didn't give you here, but it is, assumed that it's given for your schematic. The end effector position, right, is x03, y03, z03. So you can say that assuming that is the value, here is the solution. It could be any number. You know, it could be any direction. If you do that way, then it's fine. Again, that is how I, so did you understand what was his question? So Adam is asking, well, why did you do this? I don't like that. I think my robot is moving this way. Okay. That's a different, because I didn't specify, you can do that, but then after your table has to match that. Right, and then your D2 direction would be what direction? That's why it is really important if you show this first, so I know that you're solving your table because of that. Usually when you see a robot is built, you know what the directions are and you model based on that. This is an exam. I'm trying to see if you can understand and analyze how things work. So creating your function. It was RP.
Because one RP,
RP.
if D2 is in the same direction as D3, it's just one arithmetic cluster.
What's the problem with that? If you were smart enough to do it, I'll accept it. Right? RP.
Well, I mean, the thing is, for that, you're not going to get a single expression. You're going to get multiple expressions. You're going to get a linear equation.
I know. Don't worry about it. In the exam, you will know. Yeah. Don't worry about it. Don't be confused. He's asking a good question. Do you understand his question? He's saying that if this was your Z2, this whole thing is one big gigantic prismatic, right? Why you did that? Well, this was your robot. You needed to decide. I was being smart. Right? So there's a lot more to do in my table. It's like,
Okay, but like that, we're not getting used to, so you won't get it.
yeah, you would not get unique solution this exact. It would take me forever to grade. Just so you know, because all of it, for this table, you could do anything. Right? So I actually have to literally grade you one by one. There's no like mass grading. Then look at the solution.
One thing that, like, if you think both these in the same direction, with D2 and D3, you won't get an expression for either one of those.
I do get it.
No, but D2 relates to D3.
This is not real life, you know that, right?
Yeah.
In real life, this isn't this way that I showed.
But like, you're always going to have D2.
You can leave. You're done.
You're always going to have D2